Good morning, students. Today we'll start with lesson number 6, HCF and LCM. So first of all, we will start with HCF. Now, what do you mean by HCF? The full form of HCF is that H stands for highest, C stands for common, and F stands for factors. So it means highest common factor. So it means that we have to find largest possible number which can divide the given numbers exactly. So in order to find out the HCF, you should have at least two numbers, and to find their HCF, it means I have to find a largest possible number which can divide the given numbers exactly. Now let me explain you this with the example. Suppose the given numbers are 8 and 12. Suppose I have to find the HCF of 8 and 12. So I have to find HCF of 8 and 12. Now to find the HCF of these two numbers, we just need to learn the meaning of these three words, HCF. So look at these three words, highest common factor. So first of all, let us find the factors of these two numbers. Now in the previous chapter I told you what are factors. Factors are the numbers which divide the given number exactly. जो इन दोनों को exactly divide करते, those numbers are the factors of the number. So first of all, let us find out the factors of these two numbers. So what are the factors of 8? Which numbers can divide 8 exactly? I told you that the smallest factor of a number is 1 and the largest is the number itself. So 1 8s are 8 and 8 1s are 8. So both these 1 and 8 are the factors of 8. Which is the next number? Like 2 4s are 8. So 2 also is a factor of 8 and 4 also is a factor of 8. Now if I come to 3, on the table of 3 we don't get 8, so 3 is not a factor of 8. And then after that 4 2s are 8 and 4 already is there, so it means all my factors are finished. So what are the factors of 8? The factors of 8 are what are the factors? 1 2 4 and 8. 1 2 4 and 8. So these are all the factors of 8. Now what about the factors of 12? Let me take out the factors of 12. So 1 12s are 12. Now on the table of 2 2 6 are 12, and 3 also, 3 4s are 12, and after 3 comes 4 4 3s are 12, and 4 already is there. It means all my factors are over. So what are the factors of 12? The factors of 12 are 1 2 3 4 6 and 12. 1 2 3 4 6 and 12. So I have taken out the factors of, first of all I have taken out the factors of both the numbers which are given. Okay, now in the first step we have found the factors of these numbers. Now the next step is common. So next step is common, which means that we look for the common factors for each of these. Now let's take out the common factors in each of this. 1 is always a common factor of two given numbers. Now 2 also is common, as you can see 2 also is common in this, and also 4 is common in this. No other number is common a factor of these two numbers. So first of all I took out the factors, then I took out the common factors on in each of this. Now what is the third word? It's highest. Now from these common factors I have to see which is the highest common factor. So which is the highest common factor? 4 is the highest common factor. So this is how we take out the HCF of the two numbers. Okay, so HCF, it means 4 is the highest number. 4 is the highest number which is common to both of them and which is a factor of both of them. Means 4 will divide this 8 also exactly, and 4 will divide this 12 also exactly, and this is the highest number which will divide both these numbers exactly. After 4 there is no other number which can divide these both numbers exactly. Now one more thing, that this highest common factor is also called greatest common divisor. HCF is also called greatest common divisor. So, or you can say GCD. It's the same as HCF. HCF is also called GCD or greatest common divisor. Now, greatest means highest only, common, and factor also is the divisor. Factor of numbers are also there, divisors. Like this factor 4 is also known as the divisor of 8 because it divides 8 exactly. This 4 is the divisor of 12 because 4 divides 12 exactly. So this 4 is also called the divisor or the factor. So HCF is also called GCD or greatest common divisor. Now we come to exercise 6a. In the first question, they are asking you to find the HCF of the given numbers with the help of multiplication tables or by inspection. Now, how do we find the HCF with the help of multiplication tables? I am taking this example from the first question. 12 and 8. I have to find the HCF of 12 and 8 by using which method? Multiplication tables. So in this, what you can do is you take the smaller number, which is 8, and take out its factors with the help of the multiplication table. Like I told you, like 8 ke factors, 1 8 8 and 2 4s 8. 3 will not divide 8, and after that 4 comes, 4 2s 8, and it's already there. So what are the factors of 8? 1 2 4 and 8. Now from these factors which you have taken out, see whether these are the factors of 12 also. Like, yeah, for 12, 1 is a factor of every number we know. 2 is a factor of 12. Yes, 2 also is a factor of 12. 4 is a factor of 12. Yes, 4 also is a factor of 12. 4 3s are 12. 8 is a factor of 12. No. So what are the factors of 12? 2 and 4. So we can say we find 12 and 8 on the multiplication tables of what? 2 and 4. So this 12 and 8 both we get on the multiplication table of 2 and 4 only. And between this 2 and 4, which is greater? 4 is greater because I want the highest factor. So these 2 and 4 are the common factors of 12 and 8, and from 2 and 4, 4 is greater. So it means their HCF of 12 and 8 is 4. So this is how we find out the HCF with the help of multiplication tables. Now let me take one more example. This time I have taken the numbers 18 and 27, and I have to find out the HCF of 18 and 27 by which method? By using the multiplication tables. So what did I tell you? You take the smaller number is 18. Out of these two numbers, smaller is 18, and list out the factors of 18 with the help of multiplication table. Like 18 goes on the table of 1 18s are 18. Then it goes on the table of 2 also is a factor of 18. 2 9s are 18. Then 3, yes, 3 6 18. Then 4 is a factor of 18. No, on the table of 4 we don't get 18. 5 ka table don't get 18. Now 6 3 is 18, and 6 already I have. So it means all my factors are listed. So what are the factors of 18? 1 2 3 and 6 9 and 18. Now from these factors I will find out whether these are the factors of 27 also. Like 1 is a factor of every number, so 2, is this 2 a factor of 27? No, because on the table of 2 we don't have 27. 3, is 3 the factor of 27? Yes, 3 9s is 27, it means 3 is a factor of 27. 6, no, 6 ke table pe we don't get 27. 9, yes, 9 3s is 27. 18, no. So out of these factors of 18, 27 also has these common factors. So I can say both these numbers we can find on the multiplication table of 3 and 9. So both these numbers we have on the multiplication table of 3 and 9, and between 3 and 9 which is greater, because I want the highest common factor. Between 3 and 9, 9 is greater. So it means the HCF of 18 and 27 is 9. So 9 is the highest and common to both of them. So common to both of them, and a factor of 18 and 27, because 9 can divide 18 also exactly and 27 also exactly. Now one more example. Now this time I take the numbers 33 and 44. So I have to find their HCF with the help of multiplication table. So what did I tell you? First of all, take the smaller number out of these, which is 33, and take out all the factors of 33. So 133 is 33. Now you have 33 on the table of 2? No. So keep in mind the divisibility rules. Okay, so 2 के table पे नहीं आता है because this is an odd number. Does it go on the table of 3? Yes. 3 11s are 33. 4? No. On the table of 5? No. 6? No. 7? No. 8? No. 9? On the table of 9? No. On the table of 10? No. 11? Yes. 11 3s are 33, and 11 is already there. It means all my factors are listed. All my factors of 33 are listed. So what are the factors of 33? 1 3 11 and 33. Now from these factors of 33, I have to see whether they are the factors of 44 also. Like 1 is, I know, is a factor of every number. So 3 is a factor of 44? No. Is 11 a factor of 44? Yes, 11 is a factor of 44. And 33? No. So only 11 is the common factor of both 33 and 44. So we can say we find 33 and 44 only on the multiplication table of 11. Okay, so only on the multiplication table of 11 I find both these numbers. So it means their HCF of 33 and 44 is 11. Since 33 and 44 is divisible together only by 11, so this is the highest number which is common to both of them, and which is a divisor of both of them, which is a factor of both of them. Now I take the B part of the third question. In this the number given are 13 and 24, and they are asking you to find the HCF with the help of multiplication tables. So let me take the factors of 13. With smaller number is 13, so I take out the factors of 13 with the help of multiplication table. Like 1 13s are 13. So do you find 2 on the table of 2? No. 13 is a prime number which can be divisible by 1 and itself only. So what are the factors of 13? That is 1 and 13 only. And now what are the I have to see, is there any factor which is common factor of 27 and 13? No. So the factors of 13 are 1 and 13 only, and these none of these is a factor of 27. None of these can divide 27 exactly. So it means they don't have any common factor except 1, except 1. So 27 also is divisible by 1 also, and this also has a factor 1. So their common factor is only 1 and no other factor. So what I can say is that we do not find 13 and 27 together in any multiplication table. So the greatest number by which both 13 and 27 are divisible is 1 only. So it means their HCF is 1. So only they can be divisible together only by 1. They have no common factor other than 1. So it means that their HCF also is 1. Now let me take one more example like this. Suppose I have the numbers 15 and 28. So 15 and 28. Now let me take out the factors of 15 and 28. So 15 goes on the table of 1. 15s are 15. 2, no, I don't get 15 on the table of 2. 3, 5 size 15. Then comes 4, no, 4 is not a factor of 15. Then comes 5, 5 is already there. So what are the factors of 15? 1, 3, 5 and 15. So I have to find among these factors, is there any factor, is there any number which divides 28 also? So 1 is, I know, is a common factor of every numbers. So 3, do you get 28 on the table of 3? No. Is 28 divisible by 5? No. Is 28 divisible by 15? No. So what it means is that the common factor is only 1. Say, so again same, we do not find 15 and 28 together in any multiplication table. So the greatest number by which 15 and 28 are divisible is only 1. So they both can be divisible together only by 1, since they do not have any other common factor. So it means that the HCF of 15 and 28 is 1. So their HCF is 1. And do you remember I told you about co-prime numbers? So the two numbers which have their HCF 1, they are said to be which numbers? They are said to be co-prime numbers. So I'm just revising what we learned in the previous chapter. So like for the previous example I gave you 13 and 27, their HCF also was 1. So it means these two numbers are co-prime numbers, and these two numbers, because their HCF is 1, these are co-prime numbers. So what are co-prime numbers? Whose HCF is 1 means they are not divisible by any other number except 1. Now I start with the fourth question. In the fourth question, they are saying to find the HCF of the numbers by finding factors. Means I have to find all the factors of 6 and 9, and then I have to find their HCF. So let us start. So 6 ka, first of all, I will find out all the factors of 6. Like I already have explained you how to find the factors. 1 6 the 6, 2 3 the 6, after comes 2 के बाद आता है 3, and 3 is already there. So 2 3s are 6, 3 2s are 6. It means my all the factors of 6 are over now. So what are the factors of 6? 1 2 3 and 6. So 1 2 3 and 6. Now let me find all the factors of 9. So I start from 1. 1 9s are 9. 2 is a factor of 9. No. 3, yes. 3 3s are 9. So I have listed now all the factors of 9. So when you get this repetition like 3 3s and 9, it means all the factors are over. So 9 ke factors are 1 3 and 9. So I have found the factors of 6 and 9. Now I have to find the common factors in both of them. So 1 is common and 3 also is common. So 1 and 3 are the common factors, and among these 1 and 3, which is the highest common factor? So 3 is the highest common factor. So this is how we find out the HCF, by finding all the factors. So it means 3 is a common divisor of both these numbers, and it is the highest divisor, highest factor common to these. After this 3, no other factor, common factor, can divide 6 and 9 exactly. Now let me take one more example. Let me take the numbers. I can take 30 and 45. 30 and 45. Now first of all, the factors of 30. 1 30 is a 30. Now 2 also is a factor. 2 15s are 30. Now 3 also is a factor. 3 10s are 30. 4, do you get 30 on the table of 4? No, 4 is not a factor of 35. Yes, 5 6 are 30. After 5 comes 6, and 6 is already there. 6 5s are 30. So it means I have listed all the factors of 30. So what are all the factors of 30? These and these are all the factors of 30. 1 2 3 5 6 10 15 and 30. These are the factors of 30. Now let me take out all the factors of 45. So 145 is 45. Do you get 45 on the table of 2? No, because this is an odd number. So children, just remember the divisibility roots. Is this divisible by 3? Yeah. What is the divisible test of 3? You add the digits. 4 plus 5 9. So 9 is divisible by 3. So it means this number also is divisible by 3. And if you have to know where this number is divisible by 3, how many times this number is divisible by 3, so you can always divide them. 3 1s are 3 and 3 5s are 15. It means 3 15s is 45. So 3 15s is 45. Now on the table of 4, no. On the table of 5, yes. 5 9s is 45. So on the table of 6, no. On the table of 7, no. 8, no. 9, yes. 9 5s is 45, and it's already there. It means I have listed all the factors of 45. So what are the all the factors of 45? So 1 3 5 9 15 and 45. So I have to find the HCF, I have first found all the factors of 30 and 45. Now I have to find the common factors. So which are the common factors in both of them? 1 is common, 3 is common, 5 is common, and what else? 15 also is common. So what are the common factors? 1 3 5 and 15. So these are the common factors, and among these common factors, which is the highest common factor? So which is the highest common factor? 15 is the highest common factor. So it means the 15 is the greatest number which is common to both of them, and which is a divisor of both of them. So highest common factor, or we can say greatest common divisor. So 15 is the greatest common divisor of 30 and 45. Now I start with the fifth question. In the fifth question, they're asking you to find the HCF by which method? By the method of prime factorization. Now students, we have already done the method of prime factorization in the previous chapter. So what do you mean by, first of all, prime numbers? The numbers which have only two factors, which are divisible by only 1 and itself. So the prime factors of 3 are 1 and 3. The factors of 3 are 1 and 3 only. So this 3 is a prime number. Like 7, I can divide 7 only by 1 and itself. So 1 and 7 are the only two factors of 7. So 7 is a prime number. And like 11 can be divisible only by 1 and 11. So it has only two factors. So 11 is a prime number. And factorization So prime factors means the numbers which divide the given number. Exactly. So I told you how to find out the prime factorization. So prime factorization means I have to write the given number as a product of its primes, product of its prime factors. Hope you remember, we have done in the previous chapter. So to write the prime factors of a number means I have to write the product, the prime factorization will be the product of its prime factors. Now let me do this, then you will be clear with it. Like I have to find the 30, I have to find the prime factors of these numbers. I have to divide these numbers with its prime numbers only. Like I'll start with 2, which are the prime numbers I told you: 2, 3, 5, 7, 11, like this. So I start from the smallest prime number 2. So 2, I know 15s are 30, so divide this 30 with 2. 2 15s is 30. Now 15 will not be divisible by 2, so move to the next prime number, which is 3. So 3 5s is 15, and 5 itself is a prime number divisible by itself, so 5 1s are 5. So it means what are the prime factors of 30? It's 2 into 3 into 5. So this is prime factorization. Means to write the number as a product of its prime factors. So this is product, means multiply the, and all these are prime numbers only, so these are all the prime factors of 30. So as a product of its prime numbers. Now let us find out the prime factors of 75. 75 I know is not divisible by 2 because this is an odd number. Now I will see with 3. Is this 75 divisible by 3? So how to check? You add the digits. It's 12. 12 is divisible by 3. It means 75 is divisible by 3. So you can divide this with 3. 3 2s are 6 and 3 5s is 15. It means 3 25s is 75. So 3 25s is 75. Now 25 is not divisible by 3, so I have to take the next prime number 5. 5 5s are 25, and 5 will be divisible by itself. 5 1s are 5. So which are the prime factors of 75? 3 into 5 into 5. So by prime factorization means I have to find out the prime factors of these two numbers. Now I have to find the HCF. So HCF, to find the HCF, first of all I will find out the common factors of both these numbers. Like as you can see, this 3 and this 3 is common, so I will take this 3 to from both these numbers, which is common to both these numbers, and write it only once. You have to write this only once. Now which is the next factor which is common? Like this 5 and this 5 is common in both the numbers, so I will take this 5 also as a common factor and write this only once. Only once. You have to take the common factor and take it only once. So I have listed the common factors now. Now in order to take out the HCF, now what I will do is I will multiply these two common factors, 3 and 5. 3 5s is 15. So it means 15 is the highest common factor of these two numbers. 15 is the factor of these two numbers. 15 is common to both these numbers, and it is the highest number which can exactly divide these two numbers, or which is a factor of these two numbers. Now let me take one more example. Let me take this time the numbers 36 and 81. 36 and 81. So first of all what I'll do, I will find out the factors of 36. Like 2 18s is 36. 2 9s is 18. Now 9 is not divisible by 2, so I'll take the next prime number. 3 3s are 9 and 3 is divisible by itself, so 3 1s are 3. So what are the common factors of 30, what are the prime factors of 36? 2 into 2 into 3 into 3, all these divisors. Okay, now 81. So remember this, that I have to use here only the prime numbers. I have to divide them only with the prime numbers, and I have to continue till you get 1 at the end. Now 81, as I know, is a odd number and it won't be divisible by 2. Now is this divisible by 3, the next prime number? Let me check. 8 plus 1 is 9. So 9 is divisible by 3. It means this number is divisible by 3. So either you can do this in your mind, like 3 2s is 6. How much is left? 2. This becomes then 21. 3 7s are 21. Or you can always divide also, like 81 you divide with 3. 3 2s are 6. 3 7s is 21. So it means 3 27s is 81. Now 27 again is divisible by 3. 3 9s are 27. 9 again with 3. 3 3s are 9 and 3 1s are 3. So what are the prime factors of 81? 3 into 3 into 3 into 3. Now I have listed the factors of 36 and 81. Now I have to find the common factors in both of them. Like you can see here, you have 2 and 2, but here you don't have any 2, so 2 is not common, so I cannot take it. This 3 and this 3 makes a pair, both are common, so I have to take only once I have to take this common factor. Then which is the common factor? 3 is common again and this 3 is common again. So 3 and 3 again are common, so take it only once. Now here I have 3 more, 2 times more I have 3, but here I don't have any pair of this 3, so I don't have any match of this 3 over here, so I cannot take this 3. So I have to take only the common factors. This 3 is common, this 3 is common, and take the common factors only once. Now to find out the HCF, what I will do, I will multiply both the common factors. 3 3s are 9. So 9 is the HCF. So 9 is the highest common factor of these two numbers. Now let me take one more example. So let me take the example this time, 48 and 128. So what I have to do first, I have to take out the prime factors. So 2 2s are 4, 2 4s are 8. Now again it will be divisible by 2. 2 1s are 2, 2 2s are 4, 2 6 are 12, 2 3s are 6 and 3 1s are 3. So I have to continue this till I get 1 at the end. So what are the factors of 48? 2 into 2 into 2 into 2 into 3. Now the next number is 128. Now 2 6 are 12, 2 4s are 8, 2 3s are 6, 2 2s are 4, 2 1s are 2, and here 1 is left and this becomes 12. 2 6 are 12, 2 8s are 16, 2 4s are 8, 2 2s are 4 and 2 1s are 2. So how many times 2 is there? 1 2 3 4 5 6 7 times. Now factors I have taken out. Now I have, what is the next step? To take out the common factors. This 2 is common, so write it only once. This 2 is common, so write it only once. This 2 is common, so write it only once. This 2 is common, write it only once. So now here I have 3, but here I don't have any 3 and here not having any 2. So these only are the common factors. Now in order to find out the HCF, what I will do, I'll multiply all these common factors. 2 2s are 4, 4 2s are 8, 8 2s are 16. So it means the highest common factor for both these numbers is 16. So 16 is the greatest number which can divide 48 also exactly and 128 also exactly. Now students, how to find the HCF by prime factorization if you have three numbers given. Previously I have taken the examples where only two numbers were given. Now this time I have three numbers. So using the prime factorization method, I have to find out the prime factors of all these three numbers. So 2 18s are, 2 9s are, 3 3s are 9 and 3 1s are 3. Now 48. So 2 2s are, 2 4s are 8, 2 12s are 24, 2 6 are 12, 2 3s are 6 and 3 1s are 3. Now 84. 2 4s are 8 and 2 1s are 2. Now 41 is a prime number, so you must know which are the prime numbers. Okay, so 41 is a prime number which will go on its own table. So 41 ones is 41. So now what are the factors of 36? It's 2 into 2 into 3 into 3, right? And what are the factors of 48? Prime factors: 2 into 2 into 2 into 2 into 3. Now what are the factors of 84? 2 into 41. So now because we have three numbers, so we will look for the common factors in all the three numbers now, with the factors which are common in all the three numbers. Like this 2 is common in all the three numbers, so I will take the common factor 2. Now any other number, now 2 here I have, but here I don't have, so I cannot take this 2 as a common factor. Now here the factors are finished, and here you have 41, where here you don't have any 41, so I cannot take 41 also. It means 2 only is the common factor in all these three numbers, so it means HCF also will be 2 only. So it means it is the greatest number, the highest number, which is a factor of all these three numbers, which is the highest. 2 is the highest common factor of all these three numbers. Now let me take one more example, again with three numbers only. Let me take the B part. Let me take the B part: 38, 57 and 76. So let me find out the prime factors of all these numbers. 2 1s are 2, 2 9s are 18, and 19 is a prime number which will go on its own table. So 19 1s are 19. Now 57 is an odd number, cannot divide with 2, so which is the next? 3 पे जाएगा. Let me see, 5 plus 7 is 12, so 12 is divisible by 3, so it means this number is divisible by 3. 3 1s are 3, how much is left? 2, and this becomes 27. 3 9s are 27, and 19 prime number will be divisible by itself. 19 1s are 19. Now let me take 76. Now 2 3s are 6, 2 8s are 16, 2 1s are 2, and 2 9s are 18, and 19 1s is 19. Now what are the what are the factors of 38? 2 and 19. What are the factors of 57? 3 and 19. What are the factors of 76? 2, 2 and 19. Now I have to find the common factors in all the three numbers. Here you have 2, but here you don't have 2. Here you have 2, but it is not common in all three numbers, so I cannot take 2. 19 19 19. So this 19 is common to all the three numbers, so 19 is a common factor of all the three numbers, and there is no other factor which is common to all the three numbers. It means their HCF is 19 only. So all these numbers have the common factor 19. So 19 is the highest common factor or highest divisor of all these three numbers. Let me take this example now. Here I want to teach you something, like I have to find out the factors of 210. So if we have learned how to take out without dividing long with the long method, like 2 ones are 2, and then I have 1, and then I have 0. The mistake that student makes is, like, they will say 2 ones are 2, and this they will take as 10, and they will say 2 fives are 10. So this will be wrong. So this is the mistake that we people often make. Like, I have written 2 ones are 2, then next is the turn of 1. I cannot divide this 1 with 2 because it is smaller than 2, and I have to take 10 together. But first of all, I will write 0 in between because I cannot divide by 1 with 2. So first I will put a 0, and then I will take 10 together. 2 fives are 10. Let me show you this with long division. Like 2 ones are 2, you bring this 1 down. You cannot divide with 2 because this is smaller than 2. You have to bring 0 down, but first you put a 0 in the quotient. Then 2 fives are 10. So this you have to keep in mind. So this becomes 205 are 210. Now this cannot be divisible by 2, but it can be divisible by 3 because 5 plus 1 is 6, and 6 is divisible by 3. Now 3 threes are 9, and 3 fives are 15. Now not divisible by 3. Next is 5. 5 sevens are 35, and 7 being a prime number will be divisible by itself. 7 ones are 7. Now 240. 2 ones are 2, 2 twos are 4, 2 zeros are 0, 2 6 are 12, 2 zeros are 0, 2 threes are 6, 2 zeros are 0, 2 15s are 30. Now 15 is divisible by 3, 3 fives are, and 5 ones are. Now 360. So 2 ones are 2, 2 eights are 16, 0. 2 nines are 18, 0. 2 fours are 8, and 2 fives are 10. So now this will be divisible by 3. 3 ones are, 3 fives are. Now 3 fives are, and 5 ones are. Okay, now what are the factors of 210? They are 2 into 3 into 5 into 7. Now what are the factors of 240? 2 into 2 into 2 into 2 into 4 times 3 into 5. Now what are the factors of 360? 2 into 2 into 2 into 3 into 3 into 5. Now I have to find the common factors. Now since I have 3 numbers, so I have to look for the common factors in all the 3 numbers. This 2, and this 2 is common in all the 3 numbers. I have taken it only once. Now this 3, 3, yes, 3 is in all the 3 numbers. 3, 3 and 3, so it's also common in all the 3 numbers. Now 5, is it common? Yes, 5, 5 and 5, so 5 also is common in all the 3 numbers. Any other factor? Here I am left with only 7, but 7 is not in any of other, 7 is not a factor of any other number, so I cannot take 7. So only 2, 3 and 5 are common factors of all these 3 numbers, and I have to take them only once. Now to find the HCF, what I will do, I will multiply all these common factors. So 5 twos are 10, 10 threes are 30. So it means their HCF is 30. So 30 is the number, is the highest number, is the highest factor which can divide all these 3 numbers exactly. It is the 30 is the highest common factor or HCF of 210, 240 and 360.